Uh, Children, we have derived 4 equations and we did few problems in the previous class. I was just focusing on a simple idea. Motion in a straight line with a constant acceleration, right? So some kind of exercise, some kind of problems we'll be attempting now. And kinematics is such a lesson where you actually understand what to do in physics. There's not much of physics here because you don't talk about force and other things. But still, how to connect the physical situation to a mathematical set of equations. That's what you learn practically in kinematics. So let us just try some interesting sums, if not very difficult. Okay. Yes. Look at this. A particle moves along a straight line with a constant acceleration. It has velocities v1, v2 at 2 points A and B during its motion. Find the velocity at the midpoint of line AB. Find also the velocity after half the time from A. So how do we start? Particle moves along a straight line with a constant acceleration. So what shall we do? As usual, you need to picture the question. A particle moves along a straight line, right? It has velocities v1 and v2 at 2 points during its motion. We don't know where it started. We don't know where is it going up to. But the way the problem is framed, it has velocities v1 and v2 at 2 points A and B during its motion. Find the velocity at the midpoint of AB. Actually, it's not given. Try to understand. It only was told that with a constant acceleration. So what shall we do? What is that equation having v2, v1 and distance? No time. Tell me, children. What is that equation consisting of v, u and s and a?
V square minus
V square
u
minus u
square
square is equal to
equals to
AS.
So, and he's asking you the velocity at the midpoint of AB. Some unknown velocity v we need to find out. You couldn't have told that at the midpoint it is v1 plus v2 by 2. Can you? Can you say that? We don't know. Let us see. V equals how much you wanted. So let me apply v square minus u square equals to s 2 times. This v square minus v1 square equals 2a, which we don't know. We'll suppose that acceleration is a, and this distance will be how much, children? AB by 2. Distance AB by 2 here. For this and this, v square minus v1 square is 2as. A we don't know. We'll eliminate it. Now for these two, you write v2 square minus v square equals, once again, 2 into a into, once again the distance is AB by 2. So since both are equal, I can write v square minus v1 square equals v2 square minus v square. So 2v square equals v1 square plus v2 square. So v equals at 1 go, I'll write v1 square plus v2 square by 2. This can be considered an exercise problem. There's not much of difficulty here. We are simply substituting the given things in the equations known. That's what I mean by level 1 problem or exercise problem. Is it all right? Now,
Sir.
how do we do the second one? Velocity after half the time. Once again, I'll draw the same picture here. A, B. We don't know the time, but let us think it is t. So at t by 2 time, velocity, it won't be covering half the distance. Try to understand. The body has an acceleration. I told you already, if a body is having an acceleration, the later distances will be greater. So at t by 2, somewhere here, it might have had some velocity v, like this, unknown. Not the same we try to understand. It is a different problem. Since I know here v1 and v2, I'm taking some v like that. So I can write v equals u plus a into t by 2. But these two, if I write, this and this, if I write, this is the final velocity. So v2 equals initial velocity v plus a t by 2 once again. So if you make a t by 2 same, because t is not there, we'll eliminate it. What will I write? V minus v1 equals v2 minus v. So if I bring that side and write finally v1 plus v2 by 2. Just try to understand these two results in a physical sense. Okay. These two examples, two results, you try to understand something about the accelerated motion. After half the time, it's becoming v1 plus v2 by 2, but not after half the distance. Can you comment on this? But remember, though this is a simple question where from simple questions, simple problems, we can understand the concept well, because there's only one idea there. After getting the answer, let us try to interpret the answer and understand something from it. Yes, Sachit, tell me, did you see the question and the answer there?
Yes, sir.
So what's your comment on the results?
The answers are not as I expected.
No, actually, remember, formulas, application, getting the answers is all right. But every time we need to look back. After the problem analysis is very important.
Yes, sir.
First of all, after half the distance, why you cannot write v1 plus v2 by 2, you know?
Well,
Tell me.
I don't know.
Arey, yesterday only we told you like how the distances keep changing.
Okay, with acceleration constant.
Acceleration for equal time intervals, if you take, they go on increasing, isn't it?
Relatively, the distances covered will be greater.
So the whole idea of this is that, yes, definitely it's not going to be the average. This is average velocity for a constant acceleration case. This is v1 plus v2 by 2 is, we did not do even that actually, remember, but I told you when a body moves with a constant acceleration, if u is some initial velocity, v is final, average velocity I can write as u plus v by 2, I told. So that way we could write v up time after half the time as average velocity we got.
Yes.
Time velocity after half the time is coming to be equal to the average A and B. So that is something special. The reason is this, that average velocity we define is average over time, not average over distance.
Yes.
Total distance by total time we take.
Yes, sir. Yes. Got it.
Okay, let us see. But finish up the answers, children. These things keep coming back again.
Completed, sir.
Can I go to the next question, children?
Yes, sir.
Right. This is another easy question I put here. Pavani, read this.
Yes.
Hmm.
When traffic lights turn green,
Hmm.
a car waiting at the junction starts with an acceleration of 2 meters per second square.
Okay, just
At
a
the
minute.
same,
Wait. So what kind of a picture I'll put, children? Pavani, you only tell me. What kind of a picture I should put?
sir, we
Some
can
road
draw
like
at
this.
one end traffic lights.
Here we have got traffic lights. Okay.
And at the other end, a car.
On this side, car. So one car is waiting here. That means it's going to start from rest. And the truck is coming from behind.
Yes, sir.
That was a question. Isn't it so? So whether you draw it physically here or don't draw it, but imagine in the mind, but this has to be gone through. This process of visualizing has to be gone through in your mind to do physics problems. This is a traffic signal. So it was waiting means what? It is starting with
At
0 initial
rest.
velocity, but
Yes, sir.
immediately it has an acceleration of how much?
2 meters per second.
2 meters per second. And this was already coming with 20 meters per second. Am I right? Yeah.
Yes.
So when this was starting here, and this was just passing past the car. So initially, truck will be ahead of the car because it has started with 0 velocity, but is accelerating, whereas this is maintaining the speed. So definitely the car is going to catch up with the truck. Do you agree?
Yes, sir.
Yes, sir.
So let us think after a time t, somewhere from the traffic signal, they are meeting. That means the car is overtaking the truck. So from here, the distance traveled by the two things will be same, right? Huh? So S1, that is S car will be how much, children? Half A into T square. U is 0. S by truck will be what? UT. Because this speed is not changing. This is no accelerated motion. But both travel the same distance, right? So 2 to cancelling, T square equals 20T. So T equals 20 seconds. Substitute somewhere, you'll get S equals 400. Either you substitute there or here, doesn't matter. So from here, after traveling 20 seconds, when the travel distance of 400 meters, the car is going to overtake the truck. All right?
Yes, sir.
Come on. Now slowly we will increase the level of the question. So, is this all right, children?
Yes, sir.
Supposing you're not looking at the screen, can you just describe the question, Manikarnika, without looking at the screen?
Yes, sir.
Problem. Do you remember this as some truck and car problem where car is overtaking the truck from the traffic signals, something like that? That kind of a physical situation, if you can remember, life will be easy. All right.
Yes, sir.
For some are not very difficult, but still they require some kind of visualization, like what's happening. Okay.
Completed, sir.
Right. Now, next question. Slowly, the difficulty level will increase. The question is lengthy. One issue with physics problems is that they're going to be lengthy. So you should have a habit of, you should have had a habit of reading first. Reading comprehension, you must have done in your schools in a big way. Should have done. Then this would be easy. So, Tanishka, come on, read this question.
A bird flies with a speed of 10 km per hour and a car with 8 km per hour.
Yeah.
Both start from a point B and move towards.
Both start from a point B. Some point B I have here. What bird and
Car.
whatever, that is bird and a car. Okay. Move towards a point.
Towards a point A at
A.
the same instance. Given
Start together simultaneously. The distance is
40 kilometers.
right.
The bird having reached A
See, bird
flies
had a
back.
little more velocity. The car is having less velocity.
Less velocity.
Okay.
The bird having reached A flies back immediately to meet the approaching car. It flies back to A. The bird repeats
this till both the car and the bird reach A
simultaneously. Find the total distance flown by the bird.
So, the car is 8 km per hour. This is having 10. So it will go there, touch here, and then come back. By the time this would be somewhere here. Once again, it goes there and comes back. They'll be still moving. It goes there and comes back. Finally, the bird and the car will reach A simultaneously. So tell me. That is, says, for example, a bird, a pet bird, the driver has released it. So it is flying up to A, then coming back to meet the owner. Then once again, it's going to A and coming back to meet the owner, like that. Isn't it? So tell me, what should I do? Children, come on.
So first we have to calculate the time covered by car.
That's good. Very good. So it's going with a constant speed because nothing is mentioned about the acceleration, right? So time for the car will be 40 kilometer divided by
8
km per hour. How much?
5 minutes.
5
hours.
Why I don't know that. All right, no problem. 8 km per hour, 40 kilometers. Okay, no problem. That's too small. All right, then
we have to find the distance covered by the bird by substituting 5 hours in the formula. 40 into 5.
So what shall we do after that? The distance covered by the bird will be simply, the bird speed is 10 km per hour into 5 hours. So simply 50 kilometers. But understand the question is very important. Shreya, tell me.
Sir, can we do it in another way, like finding the time of the bird, and then we'll get that as 4 hours, like to reach it.
Find the time of the bird, you cannot.
Like only from B to A, sir.
Because it's going and coming back, you won't be knowing, no, how much time it took.
Sir, like initially, if we find it, the time taken from B to A before it comes back.
Try to understand this question this way.
Okay, sir.
We are not worried about the velocity of the bird. We are worried about the speed of the bird. The bird goes, reaches the car, meets the car and goes back again. But as a whole, it is taking only 5 hours time because by the time car reaches A, even bird is reaching A once again. Isn't so? So I'm using
Yes,
the
sir.
idea of distance here, not displacement. Actually the total distance is 40, but it's covering 50. Why? It's going there, coming back, going there, coming back, going there,
Laps.
isn't it? So
Yes, sir.
this is just to test you whether you have the idea of velocity and speed properly. So what is the other way you want to do? You tell me.
Sir, what I wanted to do was find the time the bird takes.
Find
And then,
how do you find the bird take? Because it is going back and forth, no?
I mean, for the first time from B to A.
First time from B to A. Okay.
And then that I got it as 4 hours. So
Okay.
in the rest 1 hour, I thought of like that.
Even that's not a bad idea. Okay. You understood what she was trying to tell? Huh?
Yes,
Because
sir.
anyway,
Yes.
bird went up to A first. So it took how much time for that?
Bird took 4 hours.
4
4
hours.
hours. Isn't it so?
Yes.
Yes, sir.
So, and this is taking, but anyway, you need to find the time with the car. Remember it. Car is taking 5, right? In the remaining 1 hour, we should cover 1 into 10, 10. So how many trips you're not worried about it, right?
Yes, sir.
So this is just looking big. How many lines actually? 3 plus 3, 6 plus 3, 9 plus 3, 12 lines it is given. But the answer is very small. Okay. Anybody
Sir,
else would like to say anything?
yes, sir.
Tell me.
By the in the first round, when the bird returns back to B, the
No, bird doesn't return back to me. It returns back to the car. And car is somewhere else.
okay.
Right?
Car is 3 by 4 hour from
Right.
B to A.
But you need not worry because the question asked is only what total distance the bird is covering.
Okay.
So anybody else to say something?
No, sir.
So if you followed, I'll move ahead because there are even better sums which will take some time. All right, children, can I continue?
Yes, sir.
Yes, sir.
Okay. Bhuvana, read this.
A particle starts from rest and moves with a uniform acceleration alpha for some time, then retards at a uniform rate beta and stops. Find the maximum velocity during the motion and the total displacement, considering the total time of motion is t.
First of all, in such kind of problems where the problem is given in general terms but not in numericals, you have to remember that you should get your answers in terms of what are given in the problem. You can suppose acceleration to be the time to be something or whatever, but that should not come. The total time, alpha, beta. What I meant to say was this alpha acceleration may be there for a time t1. This beta acceleration may be there for a time t2. But the t1, t2 don't come into picture. Try to understand. Your answer must be in terms of the things given in the problem. So that's the first thing you need to understand when a problem is given in general terms. Do you follow? So what shall I do this here?
Yes.
The cars, once again, some kind of a picture you can require. It starts from rest, it says. Right? A particle. And goes on accelerating, gets maximum velocity there. The acceleration is alpha. From there, it decelerates with beta, another acceleration, not the same alpha there. And then once again, stops. So somewhere here, it gets a maximum velocity. We can call it V maximum. Do you understand the meaning of it?
Yes, sir.
Others, please. Or somebody wants to show it in the velocity time graph, you can do that. how the uniform acceleration case will be?
Increasing and
then falls.
Yes, sir.
Slopes will be different because we don't know that alpha beta are not same. Alpha beta are not same there. Do you follow? You understand what I mean by slope being different?
Sir.
Huh? What I was trying to tell you, this time is different, this time is different. If beta had been equal to alpha, the same time you could have written, and same slope like this you could have written. Are you following that, Pavani? So this is where you got
Yes, sir.
P maximum. Say this time is T1, say this time is T2. So what equation should come to your mind, children? V equals U plus AT, right? Huh? Tell me.
Yes, sir.
So V max equals 0 plus alpha T1. T1 I don't know, right? T1 equals V max by alpha. Now here 0 velocity, here initial velocity is V max. 0 equals V max minus beta T2, children. V equals U plus AT, once again my application, nothing else. So T2 is V max by what? Beta. So T1 plus T2 is V max
Alpha plus V
1 by
max.
alpha plus 1 by beta. But this, according to the whole question, is total time. So T is V max into what will I get? Alpha plus beta by alpha beta.
Alpha
V
beta.
max will be what? Alpha beta T by. All right. So you may ask anything you want. In the beginning, I'm showing problems like this, but slowly, when the assignments are given, you are supposed to do them on your own. I want you to get into the mood of physics, basically. And then, can you guess as to how we'll do for S? Can you guess now how will I do for S? You got 4 equations, nothing else. Just from the graph, you can do like this. For example, this is going to give you the area. Area is going to give you the displacement here, right? So S1 equals half into T1 into V max. Am I correct? Half base into height. S2 equals half T2 into V max. Do you agree? Tell me.
Yes, sir.
Yes,
Area of the
sir.
triangle, what else? Why are you worried? S1 plus S2 is what? S. So V max by 2 into T1 plus T2. How much is that? T.
T.
So V max is substitute directly. Half alpha beta T. Another T is there. T square by alpha plus beta in a simple way. But otherwise, you can also write S1 S equals U2 plus half AT square.
It is.
That way also you can get it. But this is the easier way. Any questions to be asked? Children.
Sir, also seeing the graph and multiplying T into V max by 2.
Tell me again.
By seeing the graph, total displacement is equal to V max into T by 2.
V max into T by 2. Yeah.
That's it.
Yeah. Because the total base is T1 plus T2. Half into base into height for the total triangle, isn't it? And T1 plus T2 is total time T, and V max is already known from the previous one.
Yes, sir.
All right?
Yes, sir.
Right. Or you can write S equals U2 plus half a t square for this for this, and then write S1 plus S2 t, all that you can still do. Slightly lengthier. But remember, there's nothing like lengthy also in physics. In maths, of course, we can talk of elegant solutions. In physics, also we can talk, but not a, even if you cannot get a shorter solution, physics doesn't take a lot of time if your calculation capacity is good. Even if you go in the linear way and get a little late, also I have no problem, because I want the accuracy of the solving and ideas. All right, children, shall we continue? Huh?
Yes.
Yes, sir.
Right. This is something
Difficult.
small, but see how you can answer it. Shreya Dhama. Can you read the question, child? Come on. Shreya.
Initial velocity moves down. Body with zero initial velocity moves down an inclined plane from a height h and then ascends along the same plane with an initial velocity such that it stops at the same height h, in which case is the motion longer.
Time of motion longer. So how do we understand this question? Deliberately, I put it here just to make your minds become active. So how do I put my picture here? Inclined plane is like this, children. A body with zero initial velocity moves down. It starts with u equals 0. If this angle was theta, children, if this was smooth, what would be the acceleration I told you from Galileo's idea? G sine theta, right? If this is G, if this is a 90 minus theta, children, the component of G in this direction is what? G cos 90 minus theta, which is G
Sine theta.
This is what I told you as diluting gravity. We are taking it smooth. So this height is h. Okay, so this distance will be what, children? If I call it L, sine theta is h by L, isn't it so? Huh? So L is h by sine theta. So that h by sine theta distance will be covered with an acceleration g sine theta. So the body, as it comes down, will get a velocity v. Some v it gets, right? Now, if you push it up with the same v, once again the deceleration is g sine theta, right? Like if I throw a body up in under gravity upwards, whatever time it takes to go up, it will take the same time to come down because g is constant. It doesn't make a difference whether it is g or g sine theta. While going down, the g sine theta is increasing the speed, while coming up, g sine theta will decrease the speed by the same amount because acceleration is constant. Do you follow my point? So I can simply say that if there's no friction, the time should be same. You need not have to know so much about dynamics here. Just acceleration wise, if you know, that's enough. So it's an open question, open-ended question, because nothing is mentioned about the nature of the inclined plane. Rough or smooth is not mentioned. This distance L will be covered in what time? If you want, you can calculate. If you want to check it, what will you write? V equals u0 plus a. A is how much? G sine theta into what? T, of course. That v you won't be knowing. Just a minute. V square, you want to get time or velocity, whatever that's left to you. You have to find out v. You have to find out t first if you want. That is, what will I do? H by sine theta equals u is 0 plus half g sine theta into t square. What did I apply now? What did I apply? S equals ut plus half at square applied. U is 0. What do you say, children? Huh?
Yes.
So t square will be what? 2h by g sine square theta. Am I right? So 2 will be 1 by sine theta into root of 2h by g. There is time to come down. I'm proving it. I've just given it, but I was just proving it here. Do you all agree the way I did it? Tell me, boys, Balavardhan, Raviteja, and others.
Yes, sir.
Have you understood what I've done here?
Yes,
I went very slow. But now, if I calculate time to go up, I require V. See, when the final velocity, this will be initial velocity, this will be final velocity. In that case, I can write S equals Vt minus half at square, children. Can I? I told you already, no? Previously, while deriving the equations. This will make the job simple, okay? Huh? So what is S now? What is S? H by sine theta equals 0. Final velocity is 0 minus A. A is minus g sine theta now while going up into t square. So the same time will you get or not? Tell me. People are not talking, children.
Yes, sir.
Yes, sir.
So if
Yes,
the acceleration, time depends on acceleration, try to understand. So if it is a smooth plane, whatever time it takes to come down, if you project it up with the same speed, if you want, you can find the speed and project it and see. What will be the speed, children, here? V square minus u square equals 2as. So what will be V square here? U is 0, 2 into g sine theta into h by sine theta. So V square is what? 2gh. Right? So V is root of 2gh. Throw it up with the same speed. What height it goes, you can calculate if you want. Are you catching my writing here, everybody? I just showed it this way, but I'm also showing this way. I'm throwing it up with the same V, for example. V will be root of 2gh, right?
Yes, sir.
So final velocity is 0. So 0 square minus initial velocity 2gh is equal to 2 into, while going up, acceleration is the opposite direction to the velocity. So minus g sine theta into distance covered is what? H by, what is that we wanted? Time we wanted. I'm sorry. That equation won't work. Let me change. This equation is not the point. We wanted what? Time. Time to go up. What should I do then? Final velocity is 0. 0 equals u. U is how much? Root of 2gh minus a is what? G sine theta into t. They write properly. Velocity is root 2gh. Yes. 0 minus g sine theta into t. So total will be t now. Tell me. Root of 2gh by g sine theta. The same thing you got. 1 by sine theta at root of 2h by g. of course, after you did more of physics, all this you'll do without thinking, without writing so much, because the acceleration up and down are same. If it comes down and if I throw it with the same velocity, the condition is that whatever velocity it had now, with that velocity I should throw it. Then it will reach the same height, same distance it will travel and take same time. That is if the inclined plane is smooth. But if the inclined plane is rough, things will be different. If the inclined plane is rough, the situation is different. Tell me. The space was not there. I don't think you have any issue there in writing it. But if you have an issue, please ask. Because slowly the level of questions will increase. And don't be scared, because I want you to show the culture of doing few good physics problems. Children, you're not speaking. I'm really worried now. Is that all right, whatever I've done? Or
Yes, sir.
because I've written so much, you're getting confused?
No, sir.
So if there is no friction here, the time will be same for up and down. All right.
Yes, sir.
So, but if friction is there, what shall we do? I'll rub this off, children. If friction is there, what could be the idea? You do not have to do fully, you do not have to do any dynamics, nothing. That will come later, Newton's laws, all that. But little guess you can do that. You drop a body down here. Some height h. This can be theta, for example. You need to decide, look, if you write the equation for this, this velocity is v, this distance is L. If you write, what will you get, children, here? Time equals v square. No. L equals, what can I write? ut, u is 0. Half a t1 square. Well, coming down, I'll say the time is t1. So t1 will be what, children? 2L by a under root. That means it depends on acceleration. Let me call it a1. All right. Tell me, if I project it with v like this, final velocity is 0. If I write that equation once again, suppose the distance is same, it is going to same height. Vt, v is 0. You understand? Final velocity minus half minus a t square L, right? Because while going up, acceleration is opposite to the velocity. So once again, I'll get t2 equals root of 2L by a2. That means L is same for both, but accelerations are different because friction will be different. And friction will be acting in different direction. While coming down, friction acts up. While going up, friction acts down. But G sin theta is all the time downwards. While going up or coming down, G sin theta is this way, friction is that way. So acceleration to friction is backward, acceleration to gravity is forward. While going up, acceleration to gravity is backward, friction is also backward. In which case the acceleration will be more, you tell me. While coming down, it is A1, children. While going up, it is A2. So in which case acceleration is greater, you tell me.
A1 is greater than A2.
A1 is greater or A2 is greater?
Is greater.
Look, I'll tell
Otherwise,
you. Look. G sin theta is anyway downwards. So while coming down, there is another acceleration because of friction. That is some friction acceleration, you say. Some A not A, some A dash. So g sin theta down, a backwards. So the net acceleration is what? G sin theta minus a downwards. Well, going up, g sin theta is down, a is down. So the deceleration is g sin theta plus a dash here. There it is g sin theta minus a dash here. So which is more?
G sin theta plus a dash.
So this deceleration is more. That means a2 is more. You understand? That means t2 is less, t1 is longer. That means the coming time will be greater than the time going up. Tell me now. So if there's an open-ended question given there, I want your feedback. If your feedback is good, I can do better sums. If your feedback is not good, I'll go for other sums. Stia,
Yes, sir.
do you think you followed this?
Yes, sir.
Tell me, what did you follow?
So here, like in the case with friction, so while the body is going down, the frictional force is acting in the same direction.
While going down, frictional force acting in the same direction. What do you mean? Going up or going down? Coming down? When the body is released from the top, it comes down. Friction is up.
Yes, sir.
Friction is opposing g sin theta. Well, the body is coming down.
Yes, sir. And
while
yes,
going up, see, any time friction will be opposite to the relative motion, children. The inclined plane is at rest. So while coming down, the motion of the block is down, so friction will act upwards to oppose the motion. While going up also, it is, I don't know whether you understood. As this is coming down, friction is acting this way on this, I told you. As this goes up, friction acts this way, but gravity g sin theta is also this way. So this will be decelerating faster than this accelerating while coming down. So the same distance will be covered in lesser time while going up. This will take longer time while coming down. So that is what you really need to understand. If you have a problem, you tell me, because there are some even better sums than this. So I told you already, it all depends on your feedback. Here, without talking about Newton's laws, without knowing about friction, still we can try this problem from the kinematics ideas was my idea when I gave this problem. Bhuvana?
Sir?
Yes, sir.
Yogi, what do you want to say?
I'm sorry.
Nothing, sir. Nothing, sir.
Sachit, tell me.
Sir, if deceleration is more, the time taken to travel up must be greater, no, sir?
Deceleration is more, time will be less. For the
deceleration means negative acceleration, right, sir?
True. Whether it's negative or positive, try to understand. The acceleration will decide the time. If acceleration is more, it takes less time.
Yes, sir. Okay.
Of course,
okay,
we have given same velocity to go up. This is for sure that is going up, right?
Yes, sir.
Tell me. So it should go up faster because the deceleration is high. I showed it in the equations. No, time is inversely proportional to root
acceleration.
of
Okay.
Acceleration is what, children? It's not pulling the body down. Don't misunderstand. Body will be moving up only, but the velocity keeps becoming smaller and smaller, faster. So the velocity becomes zero faster in the case of going up than it is coming down. So this is looking counterintuitive for you? Tell me. The same is the case when you consider the air resistance and throw the body up. Can you tell me now? I throw a body up. Generally we say, if the air resistance is not taken into account, the body takes U by G to go up, U by G to come down. Or forget about U by G, it takes same time to go up and come down. Now, if air resistance is there while I throw a body up, what will happen from this? You can tell me. Because I'm going to talk that later, but physics is such a nice subject where you can connect things from somewhere to somewhere. If I take air resistance account,
then the time taken for it to go up will be greater.
Just now you proved that time to go up will be shorter than the time to come down. Same is the case with air friction there.
Friction and mg acts downward.
The friction acts downwards, mg acts downwards.
And mg.
Whereas while coming down, mg acts down, friction acts upward. So the acceleration becomes less. So it will be kind of a coming down slowly. Isn't it so?
Yes, sir.
Yes.
Both
Sir.
intuitive and as well mathematics, both should be understood. Shreya Dhama, do you agree with what I told?
Yes, sir.
You can take some time, be cool, but this is what we need to do, children. Don't we say, when you throw a body up, if the air resistance is not considered, the time to go up will be same as the time to come down? Don't we say this? Even in 10th class, you must have done.
Yes, sir.
But practically speaking, air resistance is always there. So if air resistance is considered, you know that it takes lesser time to go up and longer time to come down. While coming down, friction will be upwards.
Yes, sir.
So that will reduce the G. Whereas while going up,
friction and mg are downwards.
So that will increase the acceleration of the body to reduce its velocity. Right?
Yes.
So that kind of a thing you should be understanding. All right, I'll continue. Can I continue, children?
Yes, sir.
Yes, sir.
Okay. Come on. This is not a difficult question once again. Yes, M. Vaishnami. Read it, Amma.
A particle starts from the origin with a velocity of 10 meters per second.
Let me say, this is the origin. It starts with, that means U was this. Come, read. Why didn't you read? Hello, M. Vaishnavi. Children, can you hear me? Is the connection there?
Yes, sir, we can hear you, sir.
Then why Vaishnavi stopped? So it is accelerating. We don't know the acceleration, children. We're not given the acceleration. But what he says is, it accelerates until the velocity becomes some 50 meters per second. Here, the acceleration which was forward now gets reversed. So what is the time? What will be the time? What will be the velocity of the particle when it returns to the starting point? Tell me, children. Will it be 10 again? Hello, pillalu, matradandi, quick. Children, speak. Shreya.
Yes, sir.
What's happening? Remember, when the direction of acceleration changes, don't ever think the body is coming back. The body is slowing down. The body slowing down because of deceleration stops somewhere. Then since this acceleration is still there, it will be one accelerating like this. So that is the trick of the problem. Do you follow?
Yes, sir.
So this to tell you that acceleration is not the direction of motion, which I'll discuss once again in more mathematical terms. But still, you need to understand that suddenly if the acceleration direction reverses, don't think the body will start moving back like that. It doesn't start moving back like this. What will happen? The speed will go on decreasing, become zero. Then this deceleration previously now becomes acceleration. Do you understand this?
Yes, sir.
Really?
Yes, sir.
Others, Tejas,
Sir?
Shreya, yes.
Sir, I got the answer.
Tell me how much?
70 meter per second.
That's correct. That's correct. So this is what is going to happen, children. Don't say the body will go back like that. If you think it's going back like that, it will say once again 10 meters per second. Isn't it?
Yes, sir.
Sir.
So Shreya's answer is correct. So how to get it?
I use the equation v square minus u square is equal to 2as.
For what? For this first one?
I took S1, the distance traveled when u is 10 meter per second. And then S2 be the distance traveled when u is equal to 50 meter per second and v is 0 meter per second.
Yeah. So will S1 be equal to S2, Shreya?
No, sir.
It won't be. Because
S1 is coming out to be 2400.
This is having 10 meters per second velocity here. So it's becoming 0 here. So these distances cannot be same.
Yes, sir.
So you wanted the velocity back when you come back like this. Isn't it so, children? A is not known. So Shreya here, tell me, what should I do? She has got it an answer already. I want others to do it. Aryan? Have you read the full question there?
Yes, I read it.
So how should I do that? Shreya was suggesting something, you tell me. So you're saying S1, S2, I applied V square minus U square, whichever way, that's not a big deal. Why she was calculating S1, S2, you know? Because it will start and then come back with the same acceleration. Acceleration is there, right? Initial velocity is there while coming back. So if I knew the distance, I would get the velocity, is her idea. So she did it, she got it. So I have no problem with that. So can I do the same thing now? 50 square minus 10 square is equal to 2as1. So how much is this?
2400.
2400 is equal to 2as1.
1200.
1200 by this one. Isn't it so?
Yes.
Yes, sir.
Now 0 square minus 50 square is equal to 2 into minus a, I should write now, deceleration, into S2. Isn't it so? So S2 will be how much, children? 1250, yeah? 2500 by 2. How much?
Yes, sir. 1250.
So 1250 by
1250 by.
So it is what? 1 by A into 1200 plus 1250 is the distance, right? The total distance, yes. Now it goes from here to there. So unknown velocity V, if you think, V square minus 0 square equals, what will I get? 2 into same A, acceleration A into S, 1 by A into all that. Isn't it? How much is that? 24.
2450.
2450.
2450.
So this A got cancelled. So V square equals 2 into 2450. How much is this?
4900.
Oh, 4900.
4900.
70.
Right?
Yes.
Yes, sir.
Yes, sir.
I plan more sums, but only less. Okay, one more problem I'll try before I go for the next class. Let me see. Okay, this is also similar. Anyway, I'll put the PDF. Let us see. The PDF, of course, for you people, it's not available. Sums I can do tomorrow also. Not a bad thing. I'll send my PDF to you also, everybody. Just try these questions because they take some time. Okay. But if you can do 10 problems, good problems in 1 hour in the class, then that's a good rate, but all right. But anyway, I have to increase the difficulty level slowly. So if you can try these problems, tomorrow I'll discuss them. All right, children?
Yes, sir.
Okay.
Okay.
Thank you, sir.
Thank you,
PowerPoint.
Thank
Yes.
you, sir.
And the
Thank you,
PowerPoint.
sir.
Stop the share and end the session.